Oh, Sean, I corrected your maths project.
And?
Just, he knows. Okay.
Bye, Joe.
Thank you.
Bye.
Now, so, maybe we could turn the light off, please. Okay, so we're starting now next semester, maths. Okay, so just before we start, a couple of things to tell you. I checked, and it is actually in the syllabus now, for physics. In the final exam, there's 5 questions in section B, and you have to do 3 of them. And 3 of them will be from semester 2, and 2 of them will be from semester 1. And because you have to do 3 of them, it means you actually could do only semester 2 questions in section B if you wanted to. Which, you know, that's fine. I think though the semester 1 is maybe easier, but definitely in the final exam, when it comes to making your choice, you have 3 from semester 2 and 2 from semester 1, and you have to do 3, which means you have to always at least do 1 from semester 2. Okay? But anyways, I just said I checked that for you, and I checked that. The second thing then is the maths. So the worksheets are on Moodle, but I will print out your new book for you. And we're going to continue with calculus in semester 2 for the maths. Okay, so back to calculus. And we'll be at calculus for a while. The product rule. Yeah, what is this? Good question. Yes. Maths is where?
Here.
What do you mean maths is here?
Here. See.
Wow.
Yeah, you can sit here.
Yeah, you can sit there. Wait, you want to sit there? Sure, you can sit there, but you need a table. Well, I suppose you could just slide that over. I don't know what's going on. Are you moving? Yeah? Okay. Chu, could you open the window, please? Thank you. Come on, Jerry, we're all waiting for you.
Hi.
Now I have to look at you.
I don't care.
Now you have to look at me.
I'm look on math.
Okay, look at math. Good. Okay. Now, we know what the derivative of this is. For example, if I say y equals x squared, what's the derivative here? 2x, yeah, well, we know that. And if I say y equals sine x, we know the derivative here, don't we? It's cos x. But what about if I said y equals x squared sine x? Yeah, we might think it's 2x cos x, and if you think that, you would be wrong. Yes, it's not this. Some of you know this already. It's not as simple as this. And to prove why, let me have a look at a simple example. Okay, can I scroll down? Yeah. Here's a simple example. X squared is x squared. It has a derivative of 2x, for sure, right? No doubt about it. If I change y into x times x, and if I use my logic that I had a moment ago, then the derivative would become 1 times 1, which is 1, which is definitely not 2x, which is wrong. So, because I've shown it's wrong in one example, then I've shown it's not the rule. So, for maths, it's difficult to prove something is true, but it's easy to prove something is wrong. To prove something is wrong, you just need one example. So here's the one example that proves my logic from earlier is wrong. So, then what is right? What is the rule? So let's have a look at what the rule is. Can I scroll down?
Mm-hmm.
Yep. Okay. So, let's imagine we have two functions. Let's say we have y equals fx multiply gx. And we want to know what is the derivative here. So what we could do first is the first principles definition of derivative, which is x plus, well, okay, just to make this a bit clearer even, if I just call this yx, then this is yx plus h minus yx all over h. You remember this, I hope, from semester 1. So that is f x plus h g x plus h minus fx gx all over h. Yeah. Now, that doesn't help us. We still need to simplify this a bit. But before I continue, I'll just give you a minute to write this much down. Got that? Yeah. Okay. Next part's a bit tricky, so when you're ready I'll do it. So let me just get it ready here. Okay? So you can see all I've done is I've written it again, except I left a big space in the middle. So obviously I'm going to put something interesting there. So what interesting thing is going to go there? Well, what I'm going to do is put this. Minus fx gx plus h plus fx gx plus h. Now, why am I able to do this? Because it cancels and it's still 0. So this is allowed. Okay, so why did I bother doing that? Well, what's in common in the front now? Yeah, gx plus h. So let me take that out at the back. I have fx plus h minus fx, and I shall take out gx plus h. And then, what's common at the back here? Fx. And then I shall take that out in the front. Gx plus h minus gx all over h. Or, if I divide in the h, I get this. Got that? Now something interesting has happened here. Now I shall make h go all the way down to 0, so I get the derivative. So I get dy dx equals, now what the heck is this first piece going to become when h is 0?
0.
No, let Sean speak, because the rest of you are being stupid. Go on, Sean, what were you going to say? Come on, you were going to say the right answer. Go on, what were you going to say? Yeah. I saw you were going to say it. What was it? Yes? Yes? What? Yes, what's that called?
Yeah.
Good, good. You see, I'm always amazed. I've done this 20 times now. You're my 20th IFY, and every single time I ask people, what did this become? And they all say 0, 1, infinity, no answer. And it becomes this.
Yes.
Now, Sean knew that, but he didn't know the word for it. So, half points. Derivative. Because this is the definition of the derivative using first principles. Something you did like 4 weeks ago. In fact, something you did 4 minutes ago. Why did I say 4 minutes ago? Because at the very start I reminded you of the definition of the derivative using first principles. So you saw it 4 weeks ago and 4 minutes ago, but I still get the answer 0 99% of the time. It breaks my heart every time. But, you know, that's life, I suppose. Alright, continuing. Huh? Who's wasting your time?
Yeah.
What?
I'm ready.
Are you writing it down? Continue? Right, what does this part become?
G.
Gx, good. And this part? Yeah, well, this last part then? Yeah. So we have our result. This is called the product rule. If y equals fg, then the derivative of y is f derivative g plus fg derivative. Very good, Sean. Try to remember this word. This is the result. This is called the product rule. Product rule, yeah, the name of the lesson. I believe some of you have seen this before. Sean, you've seen this before? Yeah. Monica, have you seen this before? This is new. Okay. KJ, you've seen this before. Chu,
Yes.
you've seen it before? Yeah. Yeah. Jerry, has most people seen this before? Yeah. But not you, Monica. No. Have you studied the calculus chapter we did in semester 1 before? Yeah, but you didn't go on to do this stuff, is it? Okay. So you get the idea? I'll do an example now. Let's see how it works. So let's go back to a simple example. Y equals x times x. We already know what the answer is. 2x, because this is x squared, which derivative is 2x. Let's check that our rule works. I call this f and I call this g. So the rule is first derivative of f, which is and then g, yes, plus f, and then derivative of g, 1, 2x, as promised. That's our first example of the product rule. But let's do a more interesting example. Let's do the example I suggested at the start of the lesson. X squared sine x. Are you taking pictures of yourself? Okay. You know what these pictures are called? When you take a picture of yourself?
No, I didn't know.
No. Yeah, but do you know what these pictures are called?
What?
Selfie.
Yeah.
Yeah.
I was expecting something else. Something more interesting.
What?
Fancy word.
Oh, self-portrait?
Oh.
Thanks. Thank you.
Okay, can we do this example?
Yes.
Yep. Right, this is f and this is g. So, f derivative, 2x. G, yeah. Plus f, x squared. And g derivative? Okay. Yeah. Let me give you one to try. Let's say y equals x log x. Yeah. See what happens. Are those new glasses?
No,
Have I seen you wear them before?
I'm not sure.
Okay. Okay, doke. I wonder if we have answers. Monica, what did you get? Nearly. I'm not sure about the... Oh no, it could be the plus ones in there. Yeah, let's have a look. So, first derivative of x, which is 1, and then log x stays log x. And then derivative of x, which is 1. No, what am I doing? I'm sorry. X, and then derivative of log x, which is 1 over x, and they cancel, and that's exactly what you said. X log x plus 1. Yeah, very good, very good. Okay, now let me give you a slightly harder one. Or maybe before I do, if you were to guess, what do you think the rule might be if you have 3? Yeah, FGH. Yeah. F derivative GH, yeah, plus
F, G,
H, yeah.
F, G.
Yeah, so the derivative moves through the product, one by one. Good. Okay, so that's fine, there's nothing to talk about that. But let me give you this one to try. Give me the derivative of sine squared x. You got an answer, Sean?
Yes.
What did you get, Sean?
Double thing.
Yes. He said double, but you know, 2. Oh, I like double. Double sine x cos x. I like it.
He confused me.
Yeah.
What? Are you trying to say Sean's English is confusing?
No, I said double.
No. I like the double. It's true, it is double sine x cos x.
Cos that sine x.
Or double cos x sine x, yes. Okay, so I think you realise what's the trick, Sean? What's the trick? Do you know what I mean? Like, what should you do before you start? separate into sin x, sin x. Now, it's going to be cos x, sin x, plus sin x, cos x. Double sin x, cos x.
That was correct.
Correct, yeah.
Exactly.
Exactly right. Okay, good, you got that? Yeah? Okay, one more, a hard one. Can I scroll down? Find the turning point of what?
Y equal X.
Yeah, yeah, sure. Want to make it good. Yeah, that could be interesting. E minus x. Come on, I'm not finished yet. Sin x. Yeah, I like that. When there'll be multiple answers. I only care about the small answer when x is between, we'll say, 0 and pi over 2. So there'll be multiple answers. I only want the smallest x answer. Okay? I'll give you a minute. Try this.
You don't mind when I close the window?
Are you that cold?
Yeah.
Okay. Close both?
Yeah. 1.5.
Okay. 2. Close 1.5, please.
The wind's actually coming
Yes, good. Thank you. Oh, Sean. Oh, Sean.
Yeah.
What language?
Chinglish.
Chinglish?
What the?
No Chinglish. No Chinglish or Chinese. Only English. Even bad English is good.
What does E minus X become?
Oh, so much of semester 1 is forgotten. Shall I remind you?
Yeah.
Did you check your maths result?
Yeah.
And what did you get? Huh?
100.
Now, this is a true story. I didn't correct that exam. The other math teacher did. Maybe I should check this for myself. You got 100% and you're asking me this? Oh, my heart. I don't understand this class sometimes. It's AEAX.
Yeah. Why do I get a wrong answer?
How do you make wrong?
It's a good question, because you got 100%, so you know everything, except this.
Well, this is new. I thought 100 equals 0. No, in my class. I mean, my
Yeah, so what? Zero's a number. Zero's a fine number.
So x equals 0.
There's nothing wrong with that.
What?
X equals 0?
One.
For what? X or Y?
Why?
Yeah, he's giving me X. Yeah, no, but I wanted the turning point.
0.1.
Hang on.
I mean, not 0.1, I mean the...
Okay, let's have a look, let's have a look.
Zero.
Let's have a look.
Yeah.
Smarty pants. What's the derivative here?
Minus E minus
Minus
I.
x.
Sorry, I was talking to Sean.
Oh, I'm Sean.
No,
Wow.
go on, I'll let Sean. Sean can practice his words. Go ahead, Sean.
I.
Yeah? Yeah?
E.
Yeah?
Minus x.
E what?
Minus.
What do you call this?
Power.
Power, yes? Minus x, yes, yes.
Cosine.
Yes, good.
Equal.
Sean, please. Give him a chance. Equals?
E.
Equals? 0.
Give a chance.
0. Yeah? What? Why does it equal 0, Monica? Yeah, because I said I wanted the turning point.
Oh, good.
Write this down. Right, what's next? What's next?
Move. And then you can
Well, yeah, kinda. In other words, divide. Divide by what? Yeah, now why, and we have to be careful here, why is this allowed? Yeah. Like, I can divide by E minus X. But why? Because the only reason I can do this is because I know that this cannot be 0. Now that's important. So I get here cos x equals sin x, right? So 1 equals sin x over cos x, which equals tan x. So that means x equals tan inverse 1, which is pi over 4. And so y will equal e minus pi over 4 sine pi over 4, which is 1 over root 2. Yeah? So my answer is pi over 4 e minus pi over 4 over root 2.
Teacher,
Yeah.
why is it 1?
Is it not?
When cos x brings to the below of sin x,
Yep.
why is it 1 instead of 0?
It has to be
Dude, I divided both sides by cos x.
Oh.
I haven't.
Oh my God.
I'm having strong reservations now about. Yeah, no, I don't. Let me add that to my to-do list. Check Lee's result. Okay, are we happy with this? The turning points. Yeah. Oh yeah. It's much. The phone occasionally crashes. It needs to be rebooted. Did I tell you I got the cable for this? I managed to find the cable on eBay. It's very difficult to find because it's not made anymore. And not many people bought the cable when the phone came out 10 years ago. So I got the cable, I was so excited, I'm like, yay! And I managed to get it for only £10, because most people wanted £30, since there's not many of them. So I got it for £10, great, connect it to my computer, and I can't use it because I need the CD that comes with the cable, which I didn't. When I bought the cable off of eBay, it didn't have the CD with it. Now I have to find the CD.
Maybe that would be changing them.
Yeah, no, that could have been it, because the other people were like, new cable with CD. I'm like, I don't need the CD. It'll automatically work. And then when I was reading about it online, it said in the new versions of Windows, Windows 10, it no longer works. It last worked in Windows XP. I'm like, no. So then I tried installing Windows XP, and it still didn't work. This has taken up too much of my life. Okay, did you write this down? Yeah. What's what? This?
Yeah.
Tan inverse. Tan minus 1. Yeah. Okay, did you write this down? Is that breakfast?
It's not good.
Uh,
It's not good.
Very nutritious. I thought you were on this sort of protein diet.
I'm kind of over that. I don't have part organo beverage.
Ah, yes, okay, alright.
Not
Right. So the protein diet is over. The jam bakewell tart diet has begun.
But it's not delicious. I expect more delicious one, but so.
You realise you're eating that as you're saying it's not delicious.
Yeah, but I'm hungry.
Ah, okay. Okay. Right, have you all written that down? Yep. So, here's the deal for semester 2. You still have homework, but like I said in semester 1, I need to treat you like adults. I know, a mistake, probably. But you have to manage your own study yourself, because you'll have a lot to do this semester. You'll have lab reports, you'll have essays, and you'll have to do your revision for preparing for the final exam. So I don't really want to say these are the questions to do. You know from semester 1 how many questions I like to give you, and you can judge for yourself how many you can do with the time that you have. Some weeks you can do more, and some weeks you need to do less, because maybe you have an assignment due, okay? So, you know, like I said, semester 1 I tell you what questions to do, and you should do them, but in semester 2 I give you the responsibility of managing your own study. You should know how to do this now that you've finished semester 1, and you saw what worked and what didn't work, okay? So at the moment the worksheets are on Moodle. You can open up the first one called the product rule. I'll let you try this for 10 minutes, and then in 10 minutes you can take a break then, okay? But why don't you have a look at the worksheet and see which ones you think you should practice, and try to do some of them now, and you should try to do some of them at home, okay?